For the last section of our inequalities unit, we are going to talk about linear programming. So this is a method for finding a maximum profit or a minimum cost of a function over a system of inequalities. So in the real world, businesses would use something similar to this to, again, calculate how they can maximize their profits and minimize their costs. Now, this is a simplified version of some of that stuff, but it is a starting point. Now, once we are applying our linear programming to finding these numbers, we're going to need to know some vocabulary. So when we are talking about constraints, these are each of the inequalities that we are either given or we would have to find from a story problem. The feasible region is what we would get, or what we would call the shaded region of our graphs. So if we think back to our previous section, the graphs that we were shading, that overlapped part is called the feasible region. And then the objective function is an equation that we are going to use to do the calculation to figure out the maximum or minimum number. So it's going to look like this, where we have f of xy equal to our equation. Or if you are working in ALEKS, they tend to use z equals. But a lot of times, if we're talking about profit and cost, when we are writing them, we would do p equals for profit or c equals for cost. But honestly, the letters that we're picking, again, don't matter because they're placeholders, so we just need to know what they represent. And then we're going to use the vertex principle to tell us exactly which points to test to know what numbers we should be plugging into our objective function to find that maximum or minimum number. So we're just going to go over some practice of linear programming without any context, and then we are going to apply that to story problems. Okay. So if we take a look at our first example, we are going to graph the system of inequalities, and then figure out our shaded region. We're going to name the coordinates, so the vertices around that shaded region, and then we are going to plug those into the objective function. And then we are going to list whatever number is for the indicated value. So this time we're finding a maximum. Now, just so you know, for problem 1, there is a typo. This one should say x is greater than or equal to 0. So make sure you are adding that in. All right, so to start with, we need to graph the equations that were given, and in order to graph them, they need to be in y equals. So for this first one to solve, we are subtracting 5, dividing everything by 11. So we will have y less than or equal to negative 5 divided by 11x, and then 88 divided by 11 is 8. So if you need to write that out in a couple of steps, then you should be doing that. Okay. And then our next one, so getting the x by itself, this will be y less than or equal to negative x plus 14. All right, so now that we have those equations, we are just going to go through and graph them. So we're going to just do some rough sketches. So now this represents the x and y axis. So that tells me that we are not going to be dealing with any negatives. And we do want a fairly accurate rough sketch. So if you need to, you might want to use your calculator to help you come up with this picture. But it is good practice to think through it without our calculator. So I'm going to actually start with this bottom equation. So we would start up at 14, and then if we are going down 1 over 1, when we get to the other side, so to the x-axis, this is also going to be at 14. Okay. And then here I'm at 8, so somewhere in this area. And then if I'm going down 5 over 11, it's going to have a negative slope, but it's going to be a fairly flat line. So it's going to look something like this. And then because we have less than, we need to be below both of those lines. But these tell us that I have to stay in the positive quadrant. So my shading is going to be this part right here. Now, once we have our shaded area figured out, we need to identify the points around that shaded area. Okay. So it's going to be a point here, this point of intersection, this point, and then this point. So we're just going to list out those points. So the first one's easy. That's going to be at 0, 0. This point is at 0, 8. This one is at 14, 0. And then now I need to find that last point of intersection. So this is when we are going to use our calculator to help us do that. So if we could grab our calculator, and then we need to go into our y equals. So we're just going to type this equation in. So negative 5 divided by 11, negative 5 divided by 11x plus 8, and negative x plus 14. And then I'm going to press a window to make sure we have a good window. So I don't need a lot of the negatives, so I'm going to change this to be a negative 5. And then for my maximums, I want to go past 14. So I'm going to choose 16. And then 1 should be an okay scale. And then I'm going to make my y's match. So let's do negative 5, 16, and then I'm going to leave it as 1. So now I'm going to press the graph key. It's just going to graph both of our lines. Okay. So my picture is fairly close. It's a little off, but that's okay. So the important part is that we're figuring out these points, and then now we need to calculate this intersection point. So to calculate the intersection, we're going to press second trace, and then we are going to go down to number 5 where it says intersect. So enter. And then I'm just going to move this a little bit closer by using my right arrow key. So remember, if you press the up arrow key, it's going to switch the line you're on. But when this says first curve, we want this to say y1. So once I'm close, I'm just going to press enter. And then second curve, that should say y2, so enter. And then anytime we see guess, we're just going to press enter. So that intersection, that last one, is going to be at 11, 3. All right, so now that we have those points, we are just going to take them and plug them into this objective function that we were given. Okay, so remember, the first number is your x, the second one is the y. So this means I am taking 4 times 0 plus 5 times 0, and then 4 times 0 plus 5 times 8. This will be 4 times 14 plus 5 times 0. 4 times 11 plus 5 times 3. Okay? And then now we're just calculating those numbers. So looking at this, this is really the same as 0 plus 0, so that's just 0. That is 0, and 5 times 8 is 40. If we do our calculation of 4 times 14, that is going to be 56, and then that's just 0. So this will add to be 56. Here we have 44 and 15. So if we add those together, that is going to give us 59. Okay. And then this is asking for a maximum, so I'm just picking the biggest number. So let's see here. For my maximum, that is going to be 59. And if it did ask, sometimes it'll ask for the point that we would get to get this number, sometimes it won't. So if it's only asking for the maximum value, we're just saying what this number is. So my maximum value is going to be 59. And if it had asked for anything about the point, then we would just use this point to list that. All right, so if we keep going, so here is our next example. So go ahead and pause the video, and I would like you to start getting the equations graphed. All right, so again, to graph, we're going to need to solve the equations for y that aren't solved. And you're going to notice that we are going to have one that is not a nice number. So we are going to leave it as a fraction as we solve this. So this one will just become y greater than or equal to negative 3x plus 18. And then I'm subtracting 3, dividing everything by 7. So this will be y greater than or equal to negative 3/7 x plus 54 over 7. Okay. Now it is important that you type that into your calculator to get the decimal. So that's roughly 7.7. So we'll want to know that when we start doing the sketch of our graph. Okay, so adding our graph here. So that is roughly, what did we say, 7.7? So for this top equation, I'm going to be starting up at 18. And then here, 7.7 is going to be down quite a bit further. So we'll just say here-ish. And I'm also going to have a horizontal line at 12. So I'm going to need to add this one in there. So I'm going to just sketch that right away. And then this is a vertical line at 11. Okay. Now as I start adding in my other ones, so for -3, I'm going down 3 over 1. So that's going to give me a fairly steep slope. So it's going to look something like this. And then for this one, when I'm starting at that 7.7, if I'm going down 3 over 7, that's going to be a fairly flat slope. So it's going to look something like this. Okay. And then our shaded part is going to be this piece right here, because I have to be above the diagonal lines, and then below this one and to the left of this one. Okay. All right, so now I need to find all the intersection points that are touching the shaded region. So we don't care about the other intersection points. So I will have one right here, one here, here, and here. So this one will be the easiest. So if I'm at 11 for the x, and then on the 12 line, this point is at 11, 12. And then at this point, I know that my x has to be 11 because it's on this line. And then we're going to need to figure out that y value. And then at this point, I don't know what the x is, but because it's on this horizontal line at 12, I know that my y value has to be 12. Okay. And then this point, we are going to use our calculator to figure out. Okay. So it doesn't matter which point we are starting with when we are listing. So let's just go ahead and start graphing. And I'm just going to rewrite this point right away. So this will be 11, 12 for that first one. And then we'll start calculating out the rest of the others. So again, going into my y equals, I'm going to clear out what's there and type in my new equations. So -3x plus 18. And then this one will be -3 divided by 7x plus 54 divided by 7. And then for my window, I'm going to leave that at -5, and then I'm going to pick numbers bigger than 18. So I'm going to change this to be 20. And my scale of 1 should still be okay. And then I'm just going to make my y's match. So once you get your numbers entered in, we're just pressing graph. Okay. Now when we do this on your calculator, we did not type in this line, so we're not seeing that here. And same with this vertical line, so we are not seeing the vertical line. Now if we wanted to, we could go back in and type the y one. So if I go down to that third line, that would be the 12 that we would type in. Okay. But when you do that, you have to make sure you're paying attention when you start calculating intersection points. Okay. So if we start with this one, that would be this one right here. I'm going to do second trace to go to the calc menu, down to number 5. And then for my first curve, so I need to find my cursor here. So I'm going to bring it close to this intersection point. And then I need to make sure I'm on this line. So if you need to, arrow to the left and right to make sure you're on the correct line. And then you're just going to press enter. And then when it says guess, press enter. Okay, so this intersection point is at 4, 6. Okay, so 4, 6. Okay, so now you have to figure out this one and this one. So I'm going to start with this one next. So I know that my x value is 11 and that it's intersecting this line right here, which happens to be that line I wrote in equation 2. So what I'm going to do is I'm going to press my trace key, and I, again, just am going to make sure I'm on the correct one. So I'm not on the right line, so I need to be on this one. So I'm going to arrow up to switch lines, and I'm going to need to arrow up one more time. Okay, so I'm on the correct line now. So if I'm on that line, I can type the x value that I want to test. So I'm wanting to figure out 11. So I'm going to press 11 and then enter, and it's going to give me the y value at 11. Okay, so at that point then, we are at 11, 3. Okay. And then to find this point, if I graph that, we can just calculate another intersection. Okay, so again, we're trying to find this intersection right here. So I'm going to go back into my trace menu, go to intersect. And again, I have to make sure I'm on the correct lines. So I'm not on the right line, so I'm going to press up. Okay, so now I'm on this correct line, so I'm going to make this a little bit closer to that intersection I'm trying to find. So I'm going to press enter, and then I need to make sure that I'm on this line. Oh, sorry guys, my lights flickered. Okay, so I'm on the correct one, so I'm just again going to stay close, press enter, and then enter again when it says guess. Okay, so that is at 2, 12. So I'm getting that from down here, 2, 12. Now the other way that we could figure out those points is by plugging in the value that we know into the equation that it's intersecting. So an alternative way to find each of those. So again, if I go back to this one, I know that on this line, the x value is 11, which represents this equation right here. So I would just take 3 times 11 plus 7y, and then that would equal the 54. And then I would just solve this for the y value. And then I can do the same thing with this one. So again, it's intersecting this line, which is this equation. So if I know the y value, then I would just plug the 12 into the y spot. So that would give me 3 times x, and then plus 12, and that would equal 18. And then we would solve this equation for the x to get this number. So that's another way that you could approach it without using your calculator. Okay. Now once we have these, at this point, we're just plugging them into our objective function, and then this time we are finding a minimum value. Okay. All right, so if I start writing, we are taking 3 times the x and then 11 times the y. So this will be 3 times 11. Plus 11 times 12, and then 3 times 4 plus 11 times 6, 3 times 11 plus 11 times 3, 3 times 2 plus 11 times 12. All right, so now we are just simplifying that. So this will be 33 plus, let's see, 132. So if we do 11 times 12, we have 132. And then if we add that together, that will give us 165. So this is really 12 plus 66. So that is going to give us 78. And then here I have 33 plus 33. So that equals 66. And this will be 6 plus 132, which is 142. Oh, excuse me, 138. Okay. And again, if it's asking for the minimum, that is our smallest number, so that is going to be that 66. Okay, so our min value is 66. And if it had asked something to do with a point, then we would also need to list this point. So in our next set of videos, we're going to take this process and apply it to story problems.